One of the smaller planets in the inner solar system is an asteroid. Asteroids are metallic or rocky bodies without an atmosphere, ranging in size from 1-meter pebbles to a dwarf planet with a diameter of over 1,000 kilometers. The majority of the approximately 1 million known asteroids are found in the main asteroid belt, which is 2 to 4 Australian dollars from the Sun and between the orbits of Mars and Jupiter. The three categories of asteroids that are typically recognized are C-type, M-type, and S-type. These were given their names and are frequently associated with, respectively, carbonaceous, metallic, and silicaceous compositions. The largest asteroid, Ceres, has a diameter of over 1,000 kilometers, 600 miles, making it a dwarf planet. Asteroids come in a wide range of sizes. The cumulative mass of all asteroids is less than that of the moon of Earth. The bulk of asteroids in the main belt have stable, somewhat elliptical orbits that revolve in the same direction as the Earth and take between 3 and 6 years to complete one complete cycle of the Sun. In the past, asteroid observations have been made from Earth. However, the Galileo spacecraft made the first near study of an asteroid. NASA and JAXA subsequently launched a number of asteroids-focused missions, and other missions are being planned. While Dawn investigated Vesta and Ceres, NASA's Near Shoemaker studied Eros. Itaoka and Ryugu samples were investigated by the JAXA missions Hayabusa and Hayabusa 2, respectively, and returned. The Cretaceous-Paleogene extinction was caused by an asteroid collision, which is a threat to all life on Earth. There have been several different asteroid deflection theories put forth. The double asteroid redirection test was launched in 2021 and is presently traveling to Dimorphos, where it will attempt to change the asteroid's orbit by colliding with it in September 2022. This episode was made possible by brilliant throughout history. The idea of a huge space rock hurtling toward Earth has made a lot of people uneasy. It makes sense that people are naturally afraid of asteroids because if one were to actually make contact with our planet, it could trigger massive tidal waves, a brand new ice age, and an explosion that is unmatched in the course of human history. What does DART do? When will it be operational? And most importantly, how will it protect us from the greatest threat to humanity? DART is the first planetary defense project to test a means of deflecting an asteroid on track with our home planet. The Great Pyramid of Giza in Egypt is bigger than the asteroid 2021 SM3, which flew by Earth on October 22, 2021, at breakneck speeds. Perhaps the most terrifying aspect of this experience was that scientists were only able to detect the object 1 month before its close pass, meaning that if its trajectory was just slightly changed towards Earth, we would have had no chance to avoid it. Called the Double Asteroid Redirection Test, informally NASA's DART probe, which was launched just 2 months after this near-miss while atop a SpaceX Falcon 9 rocket, will finally complete its mission in late September or early October 2022, when it collides with the minor asteroid Dimorphos at a speed of about 4 miles per second. Astronomers hope that this collision will change the space rock's orbit around its larger partner Didymos. DART will show NASA that a spacecraft can find its own way to a target asteroid and collide with it. How does DART operate and what comes next? Compared to other NASA spacecraft, the DART spacecraft is small and equipped with Gen technology. The central portion of the spacecraft is a box that is only 1 meter across overall and has 2 roll-out solar arrays that give it a span of around 40 feet. The spacecraft will repeatedly orbit the Earth using its electronic engine to gradually build the necessary speed to break out of orbit. It will then begin the long journey to Didymos, possibly passing another asteroid named 2001 CB21 along the way. DART actually only has one piece of science equipment named Draco, a high-resolution camera that can take high-resolution pictures. The primary spacecraft will switch to an autonomous navigation mode 4 hours before impact, since it will be too far from Earth for flight controllers to operate in real time 5 days before it arrives. In order to navigate toward the latter, the spacecraft will use Draco's images to help its computer distinguish between Didymos and Dimorphos. This will enable it to use a very sophisticated guidance, navigation, and control system as well as algorithms known as Small Body Maneuvering Autonomous Real-Time Navigation, or Smart Nav. The dark craft's ability to distinguish between the two asteroids will enable it to focus on its intended destination. The target asteroid is about 6.8 million miles from Earth, far from the reach of our scientists on the ground, so all of this planning, projecting, and navigating will happen within just 1 hour of impact, meaning that all of this will truly be autonomous and that it will all be over in a matter of seconds. Darks will collide with Dimorphos, causing it to orbit Dynamos for 11.8 instead of 11.9 hours, a difference of just 4.2 minutes. As a result, Dimorphos will get nearer to Dynamos. All in all, the projects will immediately bring back the data, which will be meticulously examined by the creative minds at NASA. Astronomers will be able to compare data from Earth-based telescopes before and after Dark's kinetic impact to see how much Dimorphos' orbital period altered. This is the critical metric that will inform NASA how the asteroid reacted to Dark's deflection operations. In the best-case scenario, this will give the agency a strong, reliable way to fight off an asteroid hurtling towards Earth. In the worst-case scenario, this will send them back to the drawing board. Once more, the idea of deflecting an asteroid isn't new, but it's one that NASA has been looking to investigate for a long time. They just needed to find the right asteroid system to send the craft to. These asteroids have a certain speed that is really attractive to NASA in particular. The European Space Agency's HERO mission will form a follow-up analysis of Dynamos and Dimorphos a few years after the impact, providing more data and results. Dimorphos was chosen for this journey because, despite the twin asteroid system not directly posing a threat to Earth, its size is equivalent to asteroids that might have threatened the planet. There is no way to adjust the route of the asteroid to make it more harmful because the dark spacecraft will not destroy the asteroid but instead will give it a slight nudge and change its orbit around the larger asteroid. Although it may not seem like much, the rapid impact will cause Dimorphos' speed to barely change by around 1% when it circles Dynamos. If the hit is successful, however, it will shift the Moon's orbital period by at least 73 seconds, which will cause a shift of more than a minute every 11 hours and 55 minutes when Dimorphos completes an orbit around Didymos. While there are currently no asteroids on a direct collision trajectory with Earth, measuring the momentum transfer between the spacecraft and Dimorphos will reveal how much energy is required to change an asteroid's trajectory. As a result, if an asteroid on a collision path with Earth is detected one day, NASA will now know how much momentum is required to make the asteroid avoid Earth. The idea behind them all is to slightly change the asteroid's orbital speed, which modifies the asteroid's orbit so that it won't be in the same spot to strike Earth in the future. Although this entire mission will take a long time to complete and be fully analyzed and studied, it's already progressing quite well. The dark satellites are already detecting these objects before they pose a direct threat to humans. My favorite astrophysics course includes a lecture on the interstellar travel topic in today's video. This lesson examines Proxima b, the nearest planet that might harbor life, and then addresses issues like how much liquid hydrogen would be present there and how long it would take to travel there at light speed. It even instructs about NASA's hypothetical D-star system and how firing lasers at a spacecraft would be the solution to interstellar travel. Please like and subscribe if you loved this video, and I'll see you in the next one.